Once you know how to calculate the molarity of a solution, you are then able to go into the lab and actually make that solution. And this is a really important skill. This is something that you do at the beginning of an experiment. You make up all of your solutions with their known molarities, and then you pull from those solutions throughout the experiment so that you are introducing as little air as possible. It would be bad practice to make a solution over and over and over again, because then you're introducing that random air. It's not quite as easy as it sounds. Well, no, it is easy, but if you don't think about it correctly, you're going to mess it up, and you will end up with a molarity that is lower than what you were expecting, and that is air that will carry throughout your lab. So as a reminder, you know this already, but molarity is moles over liters, and that's moles of solute over liters of total solution, and that's where people get into trouble. Is not remembering that is solution, not solvent. So let's say that I made a solution that had 25 grams of NaCl and it was supposed to be 1 liter. The mistake would be measuring out my 25 grams of NaCl and then measuring out 1 liter of water and then mixing them together. That is wrong, because the 25 grams of NaCl is actually going to take up volume. Not a lot, I'll give you that, but some. And that would increase the volume of the overall solution, which would make my volume more than 1 liter, which would decrease my molarity, right? If this number is bigger than what I think it's going to be, this number would be smaller, okay? So you need to do it in a very specific order. It's not hard, you just need to pay attention. So the things that you need to know is the mass of the solute that needs to be added, okay? The volume of the total solution, again, which is the solute and the solvent, and then the volume of a volumetric flask. Notice nowhere does it say the volume of water, okay? I never know exactly how much water I've added, but that's okay. I don't need to know that. I just need to know the volume of the total solution when everything is fully dissolved and homogeneous, okay? So the steps for actually making the solution are very simple. You just need to follow them exactly. These are them in very generic terms. When you write out these steps for yourself for a specific solution, you will add in specific information like quantities and chemical formulas, etc. So the steps. First, you need to obtain an appropriately sized volumetric flask. Remember, the volumetric flask is the one that looks like this. It has a skinny neck and then the triangular bottom, like that. Okay, and it does not have measurements going up the side like an Erlenmeyer. It just has one etched glass line. Okay, so if this is a 500 milliliter volumetric flask, if the bottom of my meniscus let's say that's my 500 milliliter line. Remember, the bottom of my meniscus needs to hit that etched line exactly. Okay, perfectly like that. So remember, that's how you read glassware. These are not good, these flasks are not good for measuring various quantities of solutions, but if I need a 500 milliliter solution, I'm going to use this. This is exactly what I want. Okay, and they come in various sizes, obviously. So if I am able to calculate the mass of the solute, which we went over that in our last lesson, that I need to make a solution, I'm going to add that mass of the solute to the volumetric flask. Ideally, you would even measure it straight into that volumetric flask so that you're not leaving some of the solute behind on a piece of weighing paper. Okay. What you do then, now you've got your dry solute in your volumetric flask, you're going to add about half the amount of water. So if it's a 500 milliliter solution, maybe I'd add about 250 milliliters of water. I'm not going to measure it, I'm just going to add it. And then what I do is I swirl the flask until the solute is fully dissolved. Okay, so what I'm doing is, by dissolving the solute, I am allowing it to change the volume that it occupies. When something is in its solid phase versus when it's dissolved, the volume is different. I want it to fully dissolve so that I don't experience that change later on. Once my solute is fully dissolved, then I'm going to fill the volumetric flask with water till the meniscus reads the appropriate volume. Okay, nowhere did I actually measure water. I measured my total volume of solution because everything is fully dissolved in here. Okay, If you understand these steps and you understand how to do a molarity calculation, then you are good to go. So for example, you need to make a 0.25 molar NaCl solution that is 325 milliliters in volume. How do you prepare the solution? So I need to make sure that I know everything that I need to know. And the thing that's missing right now is the mass in my solute. So I'm going to go ahead and solve for that. So I've got a 0.25 molar solution, so I know that's 0.25 moles of NaCl per liter. Okay, that's the strength or the concentration of my solution. My solution's only 325 milliliters though, not 1 full liter. So I'm going to do a little bit of dimensional analysis. Okay, it gets rid of my liters, and then I can multiply by 325 milliliters. Okay, and that gets me into moles. At this point, I can use my molar mass. For every 1 mole of NaCl, that's 58.5 grams of NaCl. Okay, if I do my math there, let's see, 2 sig figs, I should end up with 4.8 grams of NaCl. So that does it for a molarity calculation, but we need to describe how to actually make this solution. So here's how I would do that. Step 1, I would say add 4.8 grams NaCl to a 325 milliliter volumetric flask. You want to be really specific about your glassware. Okay, and then I would say step 2, add approximately, what are we doing here? I don't know, maybe like 200 milliliters H2O. Swirl to dissolve the NaCl. Okay, some things you want to look out for when you're practically making this solution. If when you're adding your solute, some of it gets trapped on the side of the neck on the inside, make sure when you're pouring your water that it grabs that solute on the way down. And you just want to make sure that everything makes it down to the barrel of the volumetric flask and that the salt gets fully dissolved. Okay, and then step 3, once your salt is fully dissolved, okay, then you just fill volumetric flask to the 325 milliliter mark with H2O. Okay, not hard at all. But if you do it backwards, right, if you fill it with 325 milliliters of water and then you add your salt on top of that, your volume will be artificially increased and your molarity will actually decrease. So that's why it's very important to know the order in which to make your solution.